The title of my mini talk today is Blood Clotting Cascade Made Functionally Simple. The idea is to form a clot and stop hemorrhage. And it all begins by looking at all the different factors that are responsible for clot formation. Ask yourself, what is a clot formed by? Well, it includes red blood cells in a matrix of proteinaceous material that traps platelets, and the proteinaceous material is made of fibrin. So now ask yourself where fibrin comes from. Fibrin comes from fibrinogen, and fibrinogen has to be activated. And what activates that? That's thrombin. And thrombin is formed from prothrombin. And that's a result of factor 10, X. This makes up the common clotting cascade. There are two ways to get the common pathway activated. An extrinsic pathway, which is trauma mediated, and an intrinsic pathway, which is inflammatory mediated. The extrinsic pathway is relatively simple and relies on one factor, Factor VII. Factor VII is circulating in the plasma, and when there is a break in the blood vessels, extrinsic tissue factor is exposed. The two respond together and directly activate factor 10. That is the extrinsic pathway. The intrinsic pathway also requires activation of factor 10, and that begins with knowing the acronym of the intrinsic pathway, and the acronym is TENET. The T stands for factor 12. The E stands for factor 11. The N stands for factor 9. The E stands for factor 8. And the NT is backwards. Brings us to factor 10. Therefore, working backwards from factor 10 is activated by factor 8. And factor 8 is activated by factor 9. And factor 9 is activated by factor 11. And factor 11 is activated by factor 12. Factor 12 has to be activated by circulating kallikreins in the WBC inflammatory realm. And kallikreins have to be activated by lysosomal serine proteases called lysosomal carboxypeptidases, which are directly derived from WBCs. So the intrinsic pathway begins with an inflammatory response that releases carboxypeptidases, serine proteases, which activates kallikreins, which activates factor 12, which activates factor 11, which activates factor 9, which activates factor 8, which activates factor 10. Factor 10 causes the conversion of prothrombin to thrombin. Thrombin causes the conversion of fibrinogen to fibrin. Fibrin forms a matrix which traps platelets and WBCs to form a clot. Alternatively, the extrinsic pathway is driven by trauma, which exposes tissue factor, which reacts to factor 7 and directly activates factor 10. Now, factor 10 can be enhanced by factor V 3 to 4 times. And factor V is circulating in the plasma. So when factor X becomes activated, it can be embellished by factor V. The point is that factor V is constantly being degraded so that it helps keep the system in check. If factor V cannot be easily degraded, then the factor X will be in a constant state of activation, leading to excessive clot formation, which could result in strokes or pulmonary embolism. This completes my mini lecture